Good morning, everybody. Thank you for coming to this session where we're going to introduce Kubernetes. My name is Luca Ravazzolo. I work for InterSystems as a product manager, and today I'm joined by
Jim Howell. It's not on. Jim Howell.
Yeah, it's small enough, right? Yeah. Jim works for Ontario Systems, one of our customers, and they're already in their progressing rapidly on their journey with leveraging the power of Kubernetes. So without further ado, let's go ahead and let me ask you to see and read this Dilberg strip and have a smile on your face. So, yes, always cute one, right? So we're gonna go and talk techie today again. And it's going to be interesting. And yes, things like platforms like Kubernetes are not the silver bullet for everything. We have concerns about how we maintain states and maintain high availability, fault tolerance, and scalability in the InterSystems IRIS. So let's go and have a look at how Kubernetes, though, can help us. So very quickly, we're going to see the what is Kubernetes, why is it interesting from a business point of view, from a technology point of view, and then we're going to have a look at the architecture, the basic components that helps us build this platform, and then we're going to have a look at the some of the specific components that really are important for us as a durable, persistent service within the platform. And last but not least, of course, we're going to hear from Jim and all their experiences with Kubernetes. So the application stack, we all know that we start with some HTML pages, and then we probably leverage some development framework like Angular, React, Vue, and then we need to hold states, so we get the MobX and Vuex, and we need to pack everything together, and then I need even JavaScript compilers like Babel and CSS module. Then we get into the real business logic of my application, my competency, where I really make money on as I sell the application, and then we need to talk about databases, and we haven't even started talking about operating system and infrastructure. This is all a world. It's a complex world. So let me ask you, how many of you have been to the container bootcamp on Sunday, or any container sessions? Yeah, okay, great. So we all know that we can feature all those, most of that stack in many of the layers in containers, one container or a number of containers. And if I want to play it as a developer on my laptop, that's great. We have this tool called Docker Compose that allows me to put together more than one container, and this is fantastic. But and of course, right, we all know that that Docker mantra that where we can build once, run anywhere, and operate. Of course, we add, because we are at the enterprise level as we work with InterSystems IRIS, so we need to make sure that our systems are fault tolerant, etc. We can do all that within one single machine. That's great. But what happened when I'm going, with many containers into my data center, and I open the cabinet and I've got, a dozen servers there, or going in the cloud, again, I'm getting into, the dozens or hundreds of nodes. How do you work with containers, with many containers? How do you orchestrate all that? Well, we're going to need something that can control, that knows where the containers are located, that knows what they do, so we need a platform. And this platform is the container orchestrator that we're talking about, Kubernetes. So what is Kubernetes? At a high level, Kubernetes is a configurator that allows me to really specify exactly how my application is going to work. And the interesting thing about this is that first is a declarative model, so I tell you exactly how the ultimate state of the application should be. The second thing is I'm not just saying this is the database, maybe this is the web gateway, and that's it. All of our application make use of many corollary systems around it, like DNS, load balancers, what type of storage am I using? What about secret and credential? Do I use LDAP? Do I use some other type of services? What about key, management of keys, etc.? And so you realize that my application on its own, just InterSystems IRIS, maybe some business logic, and maybe some dependencies that you have, 2 or 3 elements, just that doesn't run my application. I need a host of information, corollary systems to maintain and to really run my application. And this is exactly what a platform like Kubernetes does. So the first thing that it allows us to do is to configure the application with all those components that I need. So if you need a pink leather seat or special wheels because you're going on a track, then you configure it all. And of course, the second thing that then you need is you need a controller or a site supervisor that says, okay, given that, I need to make sure that this order is scheduled and it runs on time, and whatever was configured, it really takes place, and we start building the solution. And it checks for things, for fundamentals like, do I have the materials, do I have all the services they requires, and it's really, the controller is the person that has the intelligence, that understands what's happening on that factory floor. It also checks that no material, no services are running out, or there are issues with any of the things that we need to put together for our final solution. And so it reports back as well. It reports back to whom? It reports back to a director, and the director is very much the main orchestrator that makes sure the controller really effectively produces the job and produces the goods at the end. So enough of this analogy. Let's go and have a look in the world of container management platforms, what we have out there. Well, we have a series of platforms out there that can manage containers, and one of the first that came out was Amazon ECS for Elastic Container Services, and then they came out with AWS Fargate, and both of them do not use Kubernetes. All right, and they came out with Kubernetes later on after their experiences. There's also other platforms like Docker Swarm is another container orchestrator platform. Very simple, very nice for maybe the SMB market, small medium business type of market. There's HashiCorp Nomad that has a completely different take on that. Cloud Foundry used to have one, now they just converted to PKS, so it's a pivotal container service with a K for Kubernetes. So they implemented Kubernetes as well. And so they all do the same type of jobs, right? They control the containers, they make sure they can talk to each other, they create an overlay network, they make sure that we can use persistent storage, and they offer monitoring and logging and other services. So Kubernetes is quite different. Why is it different? Well, because it comes out from from Google, from their experiences with the Borg and Omega project. And as it came out, it just became a very, very famous open source project. At the moment, they have more than 30,000 developers that have been contributing to the project, and they organize the work even in what they call SIG, special interest groups. So if you're interested in following, services or security, networking, storage, you can go and participate in these SIGs, special interest groups, and give your opinion, giving your use case of your type of problems that you see as you work with the platform, or something that that you would like to see in the platform. And this slide is just to represent really the how Kubernetes is taken off in the container management platform market. So this is all about AWS, for example, but gives you a real understanding. So they have two different engines, I said, the ECS and the Fargate. Yet when they implemented Kubernetes, at the end of last year, it was just taking over both of the other engines together, or both of the other platforms. Quite interesting, quite staggering. And this is because if I work within Kubernetes as a platform, one of the things that I get is that it has a defined my whole configuration for the whole application solution. I can use it in AWS, but tomorrow I could just lift it because the same definition, and I could put it on-prem, for example, or another cloud. And so it gives me that application portability that obviously it's very, very valuable for any organization. So let's try then to define it as we started to see some of the aspects of Kubernetes. Well, it is a portable, as we just underlined, extensible open source platform for managing containers, right, and services. And it facilitates the declarative configuration. So that first, Ferrari configurator, it allows me to configure everything I want. And then from that declarative session, it goes and implements. And the big work of Kubernetes is really trying to maintain whatever I declare, implement it in a real effective state of the cluster. And of course, it comes with a series of services and supporting tools around it, really natively. So why Kubernetes? Let's look at it from a business point of view. It is a de facto standard. I mean, we've already seen that slide on AWS, and the other two engines that have been surpassed by now. It is available on everybody. Every cloud service provider has implemented a Kubernetes service. Even DigitalOcean, right, being a smaller, more developer-oriented, they've just launched a few months ago their Kubernetes service, for example. But more to the point, I can take Kubernetes and install it on-prem, and so I can work in a cloud manner, in a cloud operational way, provision some nodes, and then install Kubernetes there, and I go exactly the same command, exactly the same way of working that if I was on any cloud provider. So we already said that it's one of the most successful open source projects, and because it allows me to define the whole ecosystem of services that I need in order to run my application in a YAML file, then it is totally portable. I can move from AWS and I can move back on-prem on another cloud, as I said. And one of the things that happened as Kubernetes came onto the market, the Linux organization created this Cloud Native Computing Foundation, CNCF, which is trying to standardize how things work out there in the cloud. And I think this is very important, because otherwise we go back to, everybody buys IBM or everybody buys Microsoft. This way, instead, if I go to AWS, I'm not locked into AWS, and I have a portable solution. And this is exactly, some of those components that you see there on the screenshot depict really the architecture, the fundamental architecture and services that are available within Kubernetes. Right. So one thing that I wanted to ponder upon for a few seconds is the evolution of the as a code approach to cloud working. So with AWS, by leveraging their CloudFormation technology or definition, we have a single definition that allows me to create a single infrastructure on AWS, of course, and so I'm working and I'm leveraging one single cloud provider. But then in the last few years, we've seen the rise of the infrastructure as code, where I can take a tool, and a typical tool everybody knows is Terraform, where I have still a single definition, but I'm actually able to provision and work with multiple cloud. And so I can create multiple infrastructure on different cloud, and therefore I support multiple cloud providers. So what's happening now, which I think is very interesting, is that we are talking about platform as code, where I'm leveraging not so much the fact that I create one single infrastructure and that's it, and what happened to the load balancers? How do I define that? How do I use it? How do I implement that definition so that it's portable? Well, you can actually do that with Kubernetes. It allows us to think of our infrastructure, of our application in a complete way. And so, we speak about platform as code, where I have a single definition, but by its definition, by its allowing us to work at a higher abstraction layer, I can actually move that definition. And this is very powerful, in my opinion. Not only we see that in general, because I said, you can take Kubernetes, just install it yourself, on your nodes. We have large CSP, cloud service provider, like Google with the project Anthos, and Microsoft with the Azure stack. What happened is you install that software on-prem. You have the same UI, the same experience as if you were on a portal against their cloud services. So, in honor of one of our large customer, MSC, that you saw on Monday, a big port with many containers is problematic. You really need a platform to be able to handle them. And what does it really mean to manage them? How do you know where to place your container, or one of your many containers, perhaps, to create your solution? Well, it's, let me ask you, how do you know that that particular node where the platform wants to start a container is just idle, or is it is it under pressure from a memory point of view, from a CPU point of view? What happens if a container dies? What is the platform supposed to do? And how does an HTTP request that comes from the outside, for example, knows how to hit the service that you wanted to hit, and is it load balanced, and how do you define all these things? Okay, so these are some of the things that a container management platform, Kubernetes, does for you. So it is aware all the time of all the resources that are available within the cluster. And that's why when you say, okay, can you schedule this workload for me, and it might be one or more containers, it tries to fit it in the best possible way. And so the benefits of containers then, as we're asking those questions, are the answer are exactly here. Kubernetes allows me to have intelligent scheduling because it knows exactly what the nodes are doing, and if the requests I'm giving it of a particular level of CPU or storage, etc., are available in that particular node. There are characteristics of self-healing. So if a container goes down, it knows it has to reschedule it, and if there might be rules that you can apply in your definition, so then it knows to schedule it in the right place with the right resources. It can do auto-scaling, okay? So when Black Friday comes, you shouldn't have to worry about it. And of course, there's load balancing available for you. It is overall a safer way to deploy the workload, because you know that you start trusting the platform that is doing the right thing for you. And as we said, it gives you application portability. So from a technology point of view, these are interesting aspects. Why? Well, because I want to sleep well at night. And so you might find that, and I think Jim will share with us, how it just does it for you. It just comes up. You don't even know. It just fixed it up for you. And so, taking a tweet from Kelsey Hightower, one of the evangelists of Kubernetes at Google, he says, well, Kubernetes is cool because it does the job of your best system administrator, and is always there online. It never sleeps, right? It does the right thing. It does automation, implements automation, makes sure failover happens correctly. Logging and monitoring are defaulted inside the engine. So, whatever we learn from DevOps, this guy is working, and it's actually a platform. Right, so it's pretty cool. What are some of the design principles that the initiator of the project, really thought about? Well, scalability is definitely one of them, and also say the auto-scaling part. The auto-scaling part is still, in my opinion, the beginning part of that, because at the moment it's just CPU level, but even that is pretty good, right? Because if tomorrow's Black Friday and my node are all pretty, don't have much load, I know that I can grow nicely, and it does automatically for me. So that's cool. Then high availability is definitely something that is very strongly ingrained into the platform. And there's a high availability from two points of view, at least. The one is Kubernetes itself. So as you install Kubernetes, you need to make sure, but usually the cloud service provider does that for you anyway, that you have 3 of them, or 5 or 7, in odd numbers, because they have their gossip protocol, and so they always elect which is the leader, and they take care of all that. But of course, it also looks after the infrastructure, and it tells you if there's a problem with nodes and with containers, and it takes care of that. And so, as I define my application, I find that if there are any problems, if one of the nodes goes down, it says, that node's gone down, and you had 3 containers running. It's part of your workload, so I need to reschedule them somewhere else. So it takes care of all that. Portability, as I said, it's a main strong point. So although they've raised the bar in terms of the abstraction layer, the definition are very clear. There are services that allows me to define networking. There's load balancers. There's secret. There's configuration databases that I can leverage. So the whole ecosystem of, as I was saying at the beginning, redefining my full application stack, not just 2 elements or 2 containers or 2 services. And of course, we have the part of security that is available there. So for example, out of the box, you can create different namespaces, which are private areas within the cluster. So I could have a namespace for developers, one for pre-testing, pre-production, production, etc. So it's really been thought for, for the enterprise, so that we can move application in their complete sense and definition from one namespace to another, and just run with it. Let's go and have a look at the components, the main components. So the main architecture is actually very boring. It's a client-server application, right? But how is that feature? How is that built? So we have the master node, and as I said, if you want HA, of course you need 3 of them. And within that we have the API server. So the API server is the Kubernetes engine or endpoints that exposes all the services that we can work with. And therefore, once we define our YAML definition in our YAML definition, our application, we send it to the endpoint, and Kubernetes starts working on that. The typical way that we work with that is through a CLI command line interface called kubectl, kubectl, or kube control, of course, yeah, whatever you want to call it. Depends if it's on the West Coast, East Coast, and that becomes really your new shell. Okay, that's your new bash. And another analogy that people bring is, okay, so if Kubernetes allows me to redefine my application like I would, I would configure an application with my bash shell, and I say, okay, this is start IRIS, start a web gateway, do these things. Okay, I'm working at the operating system level. Kubernetes is the new operating system of the cloud era. That's the analogy some people talk about. And so kubectl becomes a new SSH. So get familiar with that. It's very easy, very powerful, and hopefully, if we have time, we can see a little demo here. So what else do we have? Well, we have a scheduler. So a scheduler, as the name says, helps Kubernetes to schedule work, and it checks that and is already aware of the type of pressure that the worker nodes have, that's it. That's his job, basically. Then what we have is we have a control manager. So a control manager, it's basically runs controllers. And there's a series of controllers. And what do controllers do? They control, they check. It was like the man on the software factory. I say, hey, do we have 4 wheels for this car? Are they available? And if they're not, I need to go and get them from somewhere. Are the resources available, etc. And yeah, so there's a series of controllers. The basic controllers like node controllers. Are all my VM, all my nodes available? Are they there? What kind of pressure they're under? Do I have issue? And obviously, I get information. The controller gets information if there are problems there. And there are controllers for an important controller is the replication controller. So if I say I want 12 nodes, 12 IRIS nodes there of my data shards, it controls that those 12 are up and running. And if they're not up and running, if I've got 10, it means that 2 are missing because the declaration, the initial definition, configuration says 12 and I've got 10. I need to do something about it. So control says, oh, I need to do something here. So let me go and check. And part of the control of this controller, API and ng, is that I can build my own controllers. And in fact, the session after this is about the Kubernetes operator. We extended this architecture. It's an open architecture that Kubernetes has, where you can build your own controllers to do domain-specific jobs, which is cool. What else do we have inside the Kubernetes master node? Well, where do we keep information? Where do we maintain, the list of nodes, for example, the list of pods, containers, and services? Everything is maintained in this database, a key value persistent database called etcd or etcd. And it backs up everything in there. And that's why it's important then that we have, at least, to make a fault-tolerant cluster, make sure that we have at least 3 nodes. So that this database can be is maintained, of course. Where does the work take effect? Where is the work scheduled? The work is scheduled in worker node or minions, that used to be called, and within there, so just the node that you provision for the cluster. Within there, then you have the concept of pod. Pod is a definition of like a VM, if you like, because they share the IP stack, they share process stack, and this is standard Linux kernel. And the pods define, my workload. So I can have more than 1 pod running inside a worker node, and a pod can have more than 1 container if you're interested. So I could have, for example, a sidecar container that gives me, my monitoring for my applications, logging, whatever. There are 2 very important components here of course, that are running within the worker node. And the first one is the kubelet. And this is the main service that really controls each node. Its responsibility is to look after each node and say, okay, I know that I got this job to do, and I got 5 containers to start up. Let me make sure they start up. And so you never start a container on the nodes by hand. Like you never go there and do a Docker run. The kubelet does the work for you. What else does it do? So yeah, it makes sure that the container specification that was given is effectively implemented in the worker node, and then it reports back to the master, to Kubernetes master node to say, hey, all okay here, or yep, there is a problem in one of the containers or one of the pods, and I need to do something. Yeah. And the other important service that we have inside each node is the kubeproxy. So kubeproxy is deals with networking, so it deals with each individual subnetworking of that node, exposes services, so I can give rules in terms of ingress and egress, and I can make sure that if somebody is coming from the outside, from the internet, and I got a web page, for example, that goes and hit the right endpoint of within all my containers. So yeah, it just performs all those functions that are network related. It can set up load balancers, for example. Yeah, and you make sure that so you can give extra rules to make sure that your network is isolated or not, depending on what kind of services you want to allow in. And of course, as I have one node, worker node, I can have many. And I believe the largest Kubernetes cluster that is known to run in the world has 5,000 nodes. So Kubernetes is pretty flexible in that respect. I need to go a little faster. We go back to a little to the fundamental unit of work, which is the pod, is the atomic execution unit of work of Kubernetes. So you don't say start this container, you say start a pod. Because you can have more than one container inside. You could have sidecar, and the way Kubernetes works with the pod is really segregates them within their Linux namespace and their for their unique IP, so they can talk to each other. If there are 2 containers inside the same pod, they can do localhost, talk to that socket. And that socket is probably open. It could be open on another container. So it's very, very flexible, and it's like a small VM. You can have pod that's stretched over nodes that are really a single unit, atomic unit of deployment within a node, and they've got many characteristics that you can read. But pretty cool. So as we used to have VM as the execution model and then container, in Kubernetes we have this new concept. It's called a pod as the smallest atomic unit of scheduling. So somebody could say, well, can we play with this? What do I need to start playing with Kubernetes if it is so interesting so I can start learning? I was going to do a demo, but last time I tried the terminal didn't come up, so we can just look at the code, that's fine. So you need 2 things, first of all. So the first is you need to provision the infrastructure and you need to install Kubernetes. You say, well, it's already problematic. Well, it could be. Or you can just go to the cloud. You could go to AWS, Azure, Google, and any cloud, DigitalOcean, and you can say, okay, just provision a cluster for me. And they ask you how many nodes you want, say 20, whatever. And then you can just connect your kube control command and say, hey, show me the nodes and show me the pods that are running. So there'll be 0 at the beginning. You need to schedule some work, and that's how easy it is, really. So let's progress with some more information. So the higher abstraction level over the pod is an object called the deployment. A deployment is a supervisor that schedule work and is perfectly ideal for those ephemeral type of jobs and workloads like web servers. So I can start 50 web servers, and on Black Friday I can tell Kubernetes if they will reach 80, 90% CPU, 100%, spin up more, and it can go up to whatever number. This is really cool, and it allows me to define my workload. The other thing that you can define is just about anything that the pod or the container needs. So I can map a port, I can mount volumes. Anything else?
Ports, volumes, and define environment variables.
Environment variable, yeah. Just like it's very similar to Docker Compose. I don't know if anybody worked with Docker Compose. So basically, yep, okay, some people at the back. So basically, when you have a container, you do Docker run, it runs the container. But what if I have 2 or 3 containers I want to run on my laptop? Docker Compose is a fantastic tool for developers to have a little cluster on their system. And the deployment is exactly the same. They're both on YAML that we all love to hate, but it works. And it allows me to define the workload. This is great. And of course, yeah, I'm saying that, other details, it has phases. You can see the deployment is in progress, is completed, is failed to try to bring up the workload, etc. And I'm just leaving a slide here to say, okay, what if I want just to run something? Okay, so the hello world with InterSystems IRIS, you can just run it quickly without defining any YAML. So I'm keeping you away from YAML, which says kubectl, create something for me. So we create a deployment. There used to be a run command, but it's just been deprecated, which was simpler, so I have to write more stuff. So create deployment, call IRIS Global Summit, for example, and just specify the image, the container image you want to run. So in this case, just the IRIS Community 2019.3 that we just released. And that just creates a deployment for you behind the scene automatically, and it gets this container up and running. Of course, I have no sockets map, nothing, so I can't even access it. I can just go into the container itself, though, and go into IRIS. So what happened there? Well, what happened is, we created the deployment, but because the deployment has a replica set availability, the definition possibility, so it's got another controller that says you can tell how many of these containers you can run, then I can just say, I can scale that service, kubectl, scale my deployment, call RSGS, replicas equal 4, and it just starts up 4 other containers. There's no ICP, there's nothing, they're completely 4 isolated here. It's just to show you how you can just start playing with the platform. So deployment is good, but I said for web services, that's great. Typical use case of ephemeral work. What about me? I've got InterSystems IRIS, I've got databases, I've got I need to maintain the state. Well, there's a different object that we can specify that's perfect for databases. That's called a StatefulSet. StatefulSet is available. It's exactly what it says. It maintains the state of the workload that we spin up, that we run, and it allows us to have stable IP addresses, stable host name, stable persistent storage. What does that mean? It means that if a container goes down, if a pod goes down, Kubernetes will pick it up again and will reassign the same IP address, the same host name, the same volume that I had mounted before. Wow, well, because of course in the volume, the persistent volume, the file system I had mounted before, I had my iris.dat, so it's important I remount it, right? And so this is exactly the service or the object within Kubernetes that you want to leverage. A quick example of a StatefulSet program. But you have the slides in your app, so you can have a look at it later. I want to make sure that Jim speaks as well. So one of the most important things for us is, of course, storage. So I'm just going to quickly talk about this. So there's three types of three levels on which you define storage. And that's why Kubernetes allows it to be portable. So an administrator will define the storage class. So is this a hard disk base or is it SSD? What type of quality of service do I want? So it's just a definition, high-level definition. Again, really abstract here. But it should map to a physical layer, okay? So if you're on AWS, it will be EBS, block storage, for example, etc. Then the administrator will say, okay, given that lot of terabytes of data, of that class of storage, I want to create some volume. So I create a persistent volume. And so, I create persistent volume with their sizes and formatted with a particular file system. And again, this is just YAML definition. It does all for you. And then as a user, as a developer, for example, a tester or an architect that want to do some stress testing, then I come to the system and say, hey, in my definition of my workload that I'm going to spin up as a developer or somebody that wants to stress test the system, I want to use a particular volume. And so in your YAML definition, you say, I want this persistent volume claim. I want to claim that particular, I want to grab that particular volume that I know is available for me. Let me use it so I can do my work. I'm going to go really fast. Make sure if you work with Kubernetes, you work with the container storage interface, not with the old plugins. Most of the providers do have that anyway. Some of the providers are available there. Pure Storage, for example, is here at our global summit downstairs. You can go and talk to them how they work with Kubernetes, containers, etc. But there's a whole host of them out there, and they're really cool. A quick storage example, I'm mounting /db of a particular storage claim called IRISDB, and here on the right-hand side, my IRISDB says I want to, mount it, and for read-write once means, only one pod can mount it for writing, of course, etc., etc. And the storage class was the solid state. And of course, Kubernetes is literally available everywhere. Okay, you can play with, with any small type of technology, and it's totally portable. And with this, I'm going to leave it over to Jim, who's going to tell us his story, how they're using Kubernetes at Ontario.
Expand that a little bit. Thanks, Luca. I am going to sit, but I'm going to sit off to the side a little bit so I can see and you can see me and I can talk. I'm going to try to be fast. People like to tell me that I'm very long-winded. And I only have 9.5 minutes. So this should be fun. First, a little bit about Ontario Systems. We're an ISP that works in the receivables management space, have for 30 years using InterSystems technology. We serve the business outsourcing, healthcare, state and local government, as well as federal government for accounts receivables. Our core enterprise products were built on InterSystems technology, like I said. Most of them, one of them in particular, probably about 35 years ago. And those are usually on-prem, or we have started hosting them. And about 6 years ago, with all those different products of differing age and different data platforms, we started putting services in the cloud because we needed to code it once, have everything integrate our core premise apps, integrate with our cloud, and we have certifications like PCI and HIPAA and everything that we have to deal with, so we only have to get one thing certified up in the cloud versus 6 different times and coding it 6 different times. So that brought us to our cloud service initiative. Offer a SaaS solution that's seamlessly and tightly integrates with our core products, deployed to cloud only. Currently, our services are written in Golang, as well as ObjectScript. So our databases are mirrored cache or Ensemble instances currently. We use blob storage in S3. We're a microservice architecture. So we've actually been using Kubernetes for about 5 years for all of our Golang pieces. And so now we're actually trying to move to a single deployment model. All of our Ensemble pieces are AMIs that we deploy on EC2 instances in AWS. So we want to get everything to IRIS in containers. I'm not going to go over a whole lot on the Kubernetes piece there because Luca did a really good job of covering why Kubernetes is, it really is awesome. We are using Amazon's EKS, their Elastic Kubernetes service, which is an additional layer of added self-healing because they actually manage the control plane for you. So it just abstracts that another level. So this, and I see Andre over there and some other people, they've heard this story, and most of you probably know these terms. It's industry, right? There's pets and there's cattle. Pets get names, you nurture them. If they get sick, you spend tons of money taking them to the vet to make sure they stay alive. Those are the stateful sets, right? Those are your databases. And then there's cattle, right? Cattle are your microservices, your application servers, and if you need more cattle, you go get more cattle. God forbid one's sick. Well, we know what happens, what ranchers might do to cattle, and that's just unfortunate. So you want as many cattle as possible, very few pets. So for us, we have 2 mirrored pairs. One is what we call key master. One is another called data store master, where all of our multi-tenant databases reside, which is a separate database per tenant. And then our key masters just config about tenants, etc. So those are mirrored pairs that have to be highly available. Our Go microservices, as well as our Ensemble cattle microservices, all communicate, well, the cache microservices communicate over ECP to the databases. So our key master and data store masters are stateful sets. So basically, I'm just going to show this. So for the past 8 months, I've had all of our Ensemble pieces converted over to IRIS with Docker containers running in Kubernetes in this cluster in my environment. So I have stateful sets and I have deployments, right? Because the deployments are exactly that. Those are the cattle that when they die, they go away and we spin up new one, we auto scale them. But with stateful sets, and what that means for us, we actually, Kubernetes allows you to do things called node affinity. So when you have mirrored pairs, right, you want your different members of your mirror in different AZs, right? You want them separated, so you can use things like node affinity to make sure that they are separated on different worker nodes and different AZs, and just gives you that HA. Likewise, you can do things like init containers. So when you stand up a deployment, you can ensure that certain things and other containers and pods are available before you actually start this container. So Luca's really touched on it. There's so many things that you can do in there. And it really is a great self-healing orchestrator. So there's just a series of pods. You can see our gateway was causing us problems the day that I took this snapshot. It restarted 686 times. But Kubernetes did that. I didn't have to do anything. It handled that all by itself. And so one thing, one story, and this never seems to get old, so I gave the pets and the cattle reference. Probably about 2 months ago, I was doing an internal demo internally at InterSystems on IRIS in Kubernetes, specifically with the stateful sets. And someone asked, well, what happens if the two worker nodes running your primary and your failover of one of your stateful sets, what if you terminate those? What's going to happen? I didn't say it, but I said, hold my beer. We're about to find out. And I went in and I found in the AWS EC2 console which two worker nodes were running my primary and failover, and just by dumb luck, it was also running one of my failover members in the other mirrored pair too. So I was getting ready to kill the two worker nodes that were running 3 of the 4 mirrored pairs. And so I played manual chaos monkey. I terminated the EC2 instances, and within 5 minutes, Kubernetes had already rescheduled those pods, those stateful sets, to other worker nodes, stood up new worker nodes for me because they noticed that I didn't have my 9 worker nodes like I did before. Rescheduled the pods came up, and since we use durable %sys in IRIS, as well as durable data, within 5 minutes, the mirrors were back up. If you looked at the mirror monitor, they were healthy, they were caught up, and I didn't touch a thing except cause all the chaos. So that is an example of how the self-healing of Kubernetes, I mean, granted, like Luca said, it's not the 100% going to fix everything, but it definitely takes care of a lot and really reduces your spend on DevOps and management. So I highly recommend it. And like Luca said, after this session is what they've done with the IRIS Kubernetes operator, what they're working on with the IRIS Kubernetes operator, that just really makes things even a lot more easier for you guys as well.
1, 2, 1, 2, yeah. Thank you, guys. Thank you, Jim. That was great.
Thank you.
What about the goldfish?
Oh, shoot. I forgot. This is the best part. So after I terminated those EC2 instances, I came up with a new saying. They're no longer just pets and cattle. The pets are actually more like goldfish, because when the goldfish die, you can replace them before your kids get home from school and see that anything happened. And that's literally what it's like, because I've come in multiple times in the morning, and I've seen that pods have died and came back up in the middle of the night, and I don't have to do anything. This is a dev environment. We use it for our devs, so it really does handle a lot of stuff. Thanks for reminding me on that.
Yeah, no problem. Yeah, thank you, Jim. Any question, guys? Yes. 1 second, the microphone is coming because we're recording. Yeah, thank you.
I know you spoke about security and namespaces, but could you elaborate what are the vulnerabilities of securing a container? And as you said, if things kind of go down in between the healing, is there any attack vector that opens up?
You take it, yeah. We can both take it.
So one of the really cool things about Kubernetes, outside of ingresses that you're allowing in through RESTful APIs, hopefully, and hopefully only, by default, all the containers can really only talk to each other. You can't talk to them outside of like kube control, right? They're not publicly exposed except for the RESTful APIs that you're exposing to the outside world.
Fair enough.
Yes, and by default, everything is really locked down. And so you actually have to go into the YAML definition that we mentioned before and say, I want to open this port at this sec off and specify which is the endpoint. So it's pretty secure by default. You can also secure the communication internally, the item, the secret item, credentials or whatever keys that you have. The Kubernetes has a secret service so that you can leverage. You can even secure via TLS the communication. So it has been thought and it's being worked on as an enterprise solution. Yeah. Any more questions? Okay, thank you very much, everybody. Hope it was useful.